Hello guys, here is a very interesting problem for you. Okay, so two machines independently, so they do not influence each other, manufacture Bakugan and Beyblade toys. They manufacture toy A and toy B. Okay, the time it takes each machine to produce a toy is exp1 distributed. So what does that mean? So basically the uh, time it takes to manufacture the toys is given by exp1. So what does that mean? What is the meaning of this? Okay, so the meaning of this is very simple, that rate of manufacturing is equals to lambda into, it is an exponential function, and lambda is equals to 1. Okay, so the rate of manufacturing of 1 or 2 is equals to uh, e to the power minus t. So lambda is equals to 1. So it basically says the manufacture average rate of manufacturing is 1 toy per unit time, but it's not 1, right? It's lambda into e to the power 1 into e to the power minus lambda t. So the time is actually, so if suppose it was 2, then the rate of manufacturing would be 2 into e to the power minus 2t. So it's a exponential function, right? It's not exactly 2, it is an exponential function, and average of this function is 2. So that's what it means, that it manufactures 2 units per unit time, 2 lambda e to the power minus lambda t. Okay, and so it does not depend on other toys. Memorylessness is that called. There is no delay between the machine produce a toy and then it starts the next toy, right? So the independence of events and memorylessness is the key things that we are looking for it. Okay, find the probability that the third toy A is manufactured before second B toy. Okay, so that is the question. Now this is not an easy question. If it was, the rate was exp 2 and exp 4, so per unit time it manufactures 2 toys on an average with a distribution and 4, then we would not have been able to solve this so easily as we done. We would have needed computers and some complicated integrals, because the rate of manufacturing is same and it does not really matter that what is the rate of manufacturing. As long as it is same, this question can be solved very easily. Okay, so since the rate of manufacturing is exactly same, so which will be manufactured first has a probability half, right? So that the toy A will be manufactured first has a probability of half. Okay, and so where do we see the probability of half? In the probability that first A is manufactured before first B has the half probability, and the probability half is actually what we get in the coin toss, right? So the question then boils down to the probability of the third A is manufactured before the second B is exactly same as 3 heads before 3 heads. It's the same question. It boils down to 3 heads before 2 tails. Okay, so this question becomes this question. Why? Because the probability is half. If it was not half, then it would have been different. Okay, so 3 heads before tails is very simple. So you can get 3 heads in a row, or you can get before the 2 tails, so you can have only 1 tail. So you can rearrangement of this. So probability of this is 1 by 8, and getting 3 heads, and probability of this is 1 by 16, and there are 4 possible ways to do this. So this would be 4 by 16, right? So 4 ways to have 3 heads and 1 tail, and the probability of that is 4 by 16, and we have counted this also here, which is counted here. So let's do this 1 by 16. Okay, so that we do not count HHHT again. So the total probability, so we can get 4 heads before tail, or we can have 3 heads and tail. So the probability of 3 heads before tail is equals to 5 by 16, which is the right answer of the question. Okay, and we can also check it with a computer program that this is indeed how to solve it. Okay, So we have an x time production, and scale is 1, which means scale is 1 by lambda. So we run this, so I can show you how to run this. So suppose the scale is 1, so we'll get sometimes more than 1, sometimes less than 1, but the average of all these is going to be 1. So few are more than 1 and few are less than. And if the lambda was 2 toys per production, so we would have to put scale as 1 by 2. And so what does that mean? So average of these numbers will be half, right? Because we are producing 2 toys per unit time, so half. So average of these numbers will be half, right? So we produce 3 toys with exponential function as given to us, and 2 toys here, and we add up all the time, and as long as the time of the first sum is less than time of the second sum, we call it a favorable outcome, and we return the percentage. And let's run it for 1,000,000 times, and we should get 5 by 16. So 5 by 16 is 31.25%. So we should be getting 31.25%, right? And what if we want to find out probability of 3 toys before the 3 toys of the second factory? We should get 50%. So let's see whether that is exactly what we are getting here. Okay, so let's see if it's exactly what we are getting. So yes, we are getting 50%. And what if we want to figure out 4 toys here before 2 toys of the other party, or 4 toys of the other party before 2 toys of us? So yeah, so but then we have to change the sign. So this is, so let's change the sign. Let's do something nice. So the time of 2 toys of the first party is more than the time of 4 toys of the second party. So we are interested in now 4 T's, and before we get 2 heads, so we have to arrange these, or this is also fine, right? So if we arrange these, so there are 5 ways to arrange this, and 1 2 3 4 5 5 by 132 and 6 by 132. So the probability of this happening is 3 by 16, and so getting 4 toys of one type instead of 3 by 16. 4 toys of one type before getting 2 toys of the other type. 1.18% is something we should be hoping to get here, that it takes more time to produce 2 toys of one factory and then the 4 toys of the, and that should happen at least how many times? We calculated it, that should happen 18.75% of the time. So yes, see exactly what we said is going to happen, right? So this works great because the rate of production is exactly the same. And if the rate of production was not exactly the same, so suppose the rate of production of A is 2 and rate of production of B is 4. So what is the probability that 4 happens before 2 of these? So I can do H T combination of these, or I can just do a plain H 4 of these before this. So so I'll need this also. So this is 1 by 32. No, okay, I made a mistake. Okay, so let's do 3. Let's keep the life easier. 3 and then H and then this, right? So let's do this 3, and so the chance of so if we say that, okay, so the chance of A getting first finished is 1 by 3, and this is 2 by 3, so we can treat it as an unfair coin. So this will be 1 by 3 to the power 4, and this will be 4 arrangements, and 1 by 3 to the power 3 and 2 by 3. So if I take 1 by 3 to the power 3 common, then I get 1 by no, I will take 1 by 3 to 4 common. So I'll get 1 here and plus inside 8. I'm getting 9 divided by, okay, yes, 9 divided by 81. So I should get 1 by 9. and now 1 by 9 is 11%, 11.11%. So we have 11.11% chance of getting 3 A's before 2 B's. Okay, and by completely ignoring exponentials and just solving this. So let's see what the code says. So the scale for this is so how many did I do? So I did 2, so 1 by 2, and scale for this is 1 by 4. Okay, and I am interested in 2 production of these and 3 production of these, and I'm interested in that these 3 produces before. So let's see if we are getting 11.11%. Obviously I know 1 by 9 was 11.1. I did not need calculator, but just for you I use the calculator. So maybe we should reduce. Oh, we got exactly 11.11. Okay, so let's see. So the rate of production, average rate of production of A is 3 units per unit time, and rate of production of B is 4 units per unit time. And we are interested in getting 4 A's. Oh, I can't add it too much because otherwise it will become a very hard problem. I'm interested in getting 3 B's before 2 A's. So I'm saying time of 3 B's is less than time of 2 A's. Okay. So what is the probability that you get an A before you get a B? So I'm saying that is 3 by 7, and the probability, so 2 by 6, 1 by 3. Yes, I'm getting 4 by 7. Okay. So I want to have 2 A's before 3 B's. Okay. So I want to have 3 B's before 2 A's. Okay. So I can have 3 B's, B, and 1 A, I'm fine. So as long as I have 3 B's and 1 A, I'm fine. So there are 4 arrangements like this, and in each arrangement I have 3 B's. So 4 by 7 cube and into 1 A. So 3 by 7, right? Or I can have 4 B's. So I can have 3 B's and then the rest does not matter, but I have counted B. So I will count this separately, right? Because if I count this, then I count BA, BB. So I will just count this separately. So this is also fine. This is not counted here in this case, the arrangement. This arrangement is separate. So this arrangement is 4 by 7 to the power 4. Okay. So this is the probability of getting 3 B's before getting 2 A's. So the sum of this is 7 to the power 4 in the bottom and 7 to the power 4 to the power 4 in the top, and 1 plus 3 by 7. 1 plus 3. So yes, so this is 4 to the 4 and 3, 7 to the power 4 and 3 and 1 and 4. Yes, 4 by 4 to the power 5 by 7 to the power 4. That is my answer. Yes. So let's do that. I hope the calculator is up for it. So let's begin. 4 to the power 5 divided by, in the bracket, 7 to the power 4. 4 to the power 5 divided by 7 to the power 4. I'm getting a 42.65% chance that we manufacture 3 B's before 2 A's. So I think we should start. So the scale for this is 1 by 3 and the scale for this is 1 by 4, and we are interested in getting 3 of the second before 4 of the first, before 2 of the first, sorry, 2 of the first. So this time we are interested in this, and we have received the answer 42% in the probability case. So let's see if the distribution satisfy this. So 42.65 is the one what we are looking for, and we are trying this for 1,000,000 times. We should do it 100,000 times. That is good enough, but that's okay. It's okay. We can have some time. Okay, so that's right. So we have discovered something. I mean, we have rediscovered something. We can say that yes, the chance is same. So it's very simple. So uh, okay, so if A has a rate of manufacturing exponential 3 and B has a rate of manufacturing exponential n1 and exponential n2, then A has a chance of finishing before the n1 plus n2. This is a chance of n2 upon n1 plus n2. So, and suppose we need 3 A's before, so this is PA, this is PB, and we need 3 A's before 4 B's. So we are looking for before 2 B's, we're looking for A chance of this, and BA combination, all the combination of this. If you calculate the probability using these things, and then you will get the exact same answer that with the distribution. Why? Because we checked it. That's why we are sure that that's what is happening. We calculated it and we checked it. You can't be more sure than that. We ran it 1,000,000 times. It's not easy to run something 1,000,000 times, right? So I hope you learned this and you can solve better questions like this, and keep learning, keep being awesome. Thanks.